Hi everybody, happy Friday. I hope you're having a great day and I hope you have a great weekend. I miss you all so much and can't wait to see you on Monday. So today's lesson is 2.13, meaning of points. Our homework is 2.13 homework. Don't forget to write that in your planner. And our learning targets today are I can explain what a point on a graph means in terms of the situation, and I can find the constant of proportionality from a graph. Go ahead, pause here, get everything written down, learning targets in your notebook and homework in your planner, and come back to me once you're ready. All right, so we have 2 slides for our warm-up today. The first slide is creating a scaled copy. We have this polygon and they want us to scale it down using a scale factor of 1/3. And on the next slide, we are creating a scaled drawing of an average door. An average door is about 80 inches tall and 30 inches wide. And you're going to use the scale of 1 unit, one of these blocks representing 10 inches. Go ahead, pause here, try both of these slides, come back once you're ready. And don't forget that to draw directly on these graphs, you need to use your line tool. All right. So don't forget, when we are multiplying by 1/3, that is the same thing as dividing by 3. So we're going to take all of these side lengths that a majority of them are 3, and then the 2 longer ones are 6. And we're going to take all of these side lengths and divide by 3. So when you do 3 divided by 3, you get 1. And 6 divided by 3 is 2. So a majority of our lines should be 1. These longer ones are going to be 2. Awesome. Make sure yours is all good. And let's go ahead and move on to the next part of our warm-up, which is the scale drawing of the door. So if one of these units represents 10 inches, one of our little boxes is 10 inches, and we need to figure out how many units do we need to make 80 inches and how many to make 30? Well, we can either count by tens or we can divide these numbers by 10. So 80 divided by 10 is 8. And 30 divided by 10 is 3. So the width is going to be 3, and the height is going to be 8. 2, 4, 6, 8. And this is what your scale drawing should look like. It does not matter if it is tall or if it is long. It does not matter which way you have your rectangle, as long as it's an 8 by 3. Okay, double check all your sides. And let's go ahead and move on to picking apples. So our first activity of today is picking apples. We have this graph that represents the relationship between the pound in apples picked and the price in dollars for those apples. Our first question is, what is the coordinate point for this point K? What does this point represent in terms of the situation? And what is the constant of proportionality for this graph? And what does it tell you about this situation? Remember, we did 2 problems just like this yesterday in our notes. So if you need to go back and look, you can. But go ahead and pause here and try these 3 problems. All right, so coordinate point K. We went over 12 and up to 24. So the coordinate point is going to be 12, 24. Next, it wants to know, what does this mean in terms of our situation? So it's going to be apples and price. Now, 12 represents our pound in apples, and our price is going to be 24. So 12 pounds of apples cost $24. Now our constant of proportionality. Remember, on a graph, the constant of proportionality is when our x is 1. Now, we don't have 1 on this graph because we're counting by 2, so it skipped over 1. You might be able to figure out what x is without creating a table, but we're going to go ahead and create a table just so we fully know what it's going to be. So we are talking about our pounds in apples and the price in dollars. We know 12 pounds cost $24, and we want x, our pounds in apples, to be 1. To go from 12 down to 1, we need to divide by 12. 12 divided by 12 is 1. And since we divided this side of our table by 12, we also must divide this side of our table by 12. 24 divided by 12 is 2. So our constant of proportionality is 2, because that is what is next to 1 in our table. On the coordinate point, on the graph, it would be the coordinate point 1, 2. And what this means, again, 1 is our x, it is the pounds of apples. 2 is how much it's going to cost. 1 pound of apples cost $2. 1 pound of apples costs $2. Make sure you've got all this. Okay. Now let's go ahead and move on to the next slide. On the next slide, we're still going to be looking at this same graph, but we're going to have a few different questions about it. So this time our questions are, what does the point 1734 mean? If we picked 25 pounds of apples, how much will we pay? And if you have $18, how many pounds of apples can you pick? Go ahead, pause here. Try these problems and come back to me once you're ready. Okay, so the point 1734. So remember our x value, that first value is the pounds of apples, and the second number is our price. So this is 17 pounds of apples. Costs $34. For the next one, we are going to use our constant of proportionality. So remember, 1 pound of apples costs $2. That means we multiply our pounds of apples by 25. We can create a table here. Pounds of apples cost in dollars. We know 1 pound is $2. We're looking at 25 pounds. So from pounds to price, our constant proportionality is 2. We're multiplying by 2. So we're going to do 25 times 2. That is going to give us 50. So it's going to cost $50 for 25 pounds of apples. Now, for number 6, we want to go backwards. We know our price, but we want to go backwards to the amount of pounds. We're doing the opposite this time. Last time we multiplied by 2. This time we're going to divide by 2. So we're going to do 18 divided by 2, which is 9. So we can buy 9 pounds of apples. All right, make sure you have all this down. And let's go ahead and move on to our next activity. Now we're going to look at calories in low-fat milk. Again, we have a graph. Our X value is servings of low-fat milk. Y is now calorie count. So you're going to tell me, what is the coordinate point for point F? What does it mean in terms of the situation? What is our constant of proportionality? What does it tell you about this situation? You can go ahead, pause here, do these 3 problems, come back once you're ready. All right, so point F, we go over 4 and up 408. So the coordinate point is 408. Now what this means, 4 represents the servings of low-fat milk, and then 408 is the amount of calories in it. So 4 servings has 408 calories. For our constant of proportionality, again, we can create a table where we have servings and calories. We know 4 servings, it's 408 calories. And if we want to go down to 1, we would divide by 4 on both sides and get 102. We can also see that on the graph actually. So X value has a 1. And when we go up to our line, we see that 1 serving a calorie is going to be 102. So it is 102 for our constant of proportionality, and we see that on the graph as 102. Now this tells us that 1 serving has 102 calories. Okay. Get all that down. And let's go ahead and move on to our next slide. Again, we're still looking at this graph, but some new questions. So, new point, 918. What does this mean in terms of the situation? If we have 5.5 servings, how many calories is it? If there is 1,224 calories, how many servings is it? Go ahead, pause here, try this this slide, come back once you're ready. All right, so point F, I'm sorry, not point F, we already did that. 918. Again, that first number 9 is the amount of servings. The second number is our calories. So 9 servings has 918 calories. For number 5 and 6, again, we need to use our constant of proportionality, which is 102. We're going to look at a table again. We know 1 serving has 102 calories. So we're going to look at 5.5. So first of all, we know from servings to calories that constant of proportionality is 102. That means we multiply our servings by 102 to get the calories. So we're going to do 5.5 times 102. Don't know why I added a decimal there. And when we do that, checking my answer key, we get 561. So it is 561 calories. For the next problem, we're given the amount of calories and asked to find the amount of servings it would be. So we know that going from servings to calories, we multiply by 102. So going backwards, we're going to divide by 102. So we're going to take 1,224, divide by 102, and that is going to give us 12. So this will be 12 servings. Get all that down. All right, now let's go ahead and move on to our next slide. Let's go canoeing. So you can rent a canoe at a place, and this graph shows the relationship between the amount of hours that you rent a canoe and the total cost of renting that canoe. So we're given point D. What is that coordinate point? What does it represent in the terms of the situation? what is our constant of proportionality for this graph, and what does it tell you about this situation? Okay, you can tell we're getting repetitive. So go ahead, try this slide, come back to me once you're ready. All right, so point D, you can see we go over 8 and up 96. So our coordinate point is going to be 8, 96. What this means, so 8 is the amount of hours, 96 is going to be the cost. So after 8 hours, it costs $96 to rent that canoe. And now it wants to know what our constant of proportionality is. Again, it's when our x value is 1, we can create a table. We're looking at hours and cost. We know 8 hours costs $96. And if we're trying to take our hours, our x value down to 1, we're going to divide by 8. 96 divided by 8 is 12. So our constant of proportionality is 12. We see that on the graph at the point 112, so over 1. And when we go up, it's not marked, but this would be 12. And now, what does this tell us? Well, 1 is hours, our price is 12. So after 1 hour, it costs $12. Okay. Great job. And let's go ahead and move on to the next slide. Again, same graph, new questions. This time, what does the point 448 mean? If you rent the canoe for 3 1/4, 3.25 hours, what would the cost be? And how many hours can you rent a canoe for if you have $144? Pause here, try these problems, come back to me once you're ready. All right, so the point 448. 4 is our x value, it's how many hours we're renting it for. 48 is the cost. So after 4 hours, it costs $48. Now for 5 and 6, again, we can create a table. We need to use our constant of proportionality to find it. So we know our hours and the cost. After 1 hour, it costs $12. And now we want to look at 3 1/4 hours. We're going to use our constant of proportionality, which is 12. That means we can take our amount of hours, multiply it by 12 to get the price. Don't go blurry on me. So we're going to take 3 1/4, multiply it by 12, and that is going to give us 42. So it's going to cost $42 to rent it for 3.25 hours. Now for the next one, it wants to know $144 will give us how many hours. So from hours to price, we've been multiplying by 12. To go backwards, we're going to divide by 12. So 144 divided by 12 is 12. So we could rent it for 12 hours. Make sure you got all this. We've only got 2 more slides. All right. Now, the Earth versus the Moon. So this graph shows the relationship between an object's weight on Earth and the object's weight on the Moon. So we should know, hopefully your science teacher has taught you at this point, that gravity on the Moon is less. There's not as much gravity, so that means things weigh less on the Moon than they do on Earth, and it is a proportional relationship. So Number 1, what is the coordinate point? What is the coordinate point for M? What does it mean in terms of the situation? What is our constant of proportionality? That one's going to be tricky. And what does it tell you about our situation? Go ahead, pause here. Come back to me once you are ready. All right, so our coordinate point, we went over 12 and up 2. So the coordinate point is 12, 2. In terms of the situation, 12 is our weight in pounds on Earth. 2 is going to be weight in pounds on Moon. So this means 12 pounds on Earth is equal to 2 pounds on the Moon. Wants to know what the constant of proportionality is. It is not 6. It is not 6. Okay, I know a lot of you are thinking, well, 2 times 6 is 12, but remember, we want when our weight in pounds is 1, not when the y value is 1. So I know when y is 1, x is 6, but we want when x is 1. However, that 6 is going to help us. So, create our table. I'm going to do Earth weight versus Moon weight. We know on Earth 12, Moon 2. Now, we're going to go backwards a little bit. So we're going to look at when the Moon is 1. When the Moon is 1, Earth would be 6. But again, that's not what we want. We want when the Earth is 1. Now remember, constants of proportionality. There's always 2. One of them is 6. This is not the constant of proportionality we want. We want when x is 1. However, these 2 constants of proportionalities will always be reciprocals. Remember, a reciprocal is when a fraction is doing a handstand, when a number is doing a handstand. 6 doing a handstand is 1 over 6. So, the constant of proportionality right now is going to be 1/6. That point would be 1/1/6. And this means that 1 pound on Earth is 1/6 of a pound on the Moon. Great job. Great job. Now, let's go ahead and move on to our very last slide. Same graph, new problems. What does the point 24 mean? If an object weighs 36 pounds on Earth, what would it weigh on the Moon? And if an object weighs 36 pounds on the Moon, what would it weigh on Earth? Pause here, try these problems, come back once you're ready. All right, so what does the point 24 mean? Well, 24 is our x value, that's the weight on Earth, and 4 is the weight on the Moon, that's our y value. So 24 pounds on Earth is the same as 4 pounds on the Moon. For number 5 and number 6, we can create a table. Earth weight and Moon weight. Sorry, I messed that up. Okay, so I put our 2 constants of proportionality in here because they're both going to help us. So, we want to know if the Earth is 36 pounds. I'm sorry, on Earth, if an object is 36 pounds, how much would it weigh on the Moon? So, from Earth to Moon, our constant of proportionality is 1/6. That means we're going to multiply our weight that is on the earth, that is 36. We're going to multiply it by 1/6. Remember, multiplying by 1/6 is going to be the same as just dividing by 6. So that is 6. So on the moon, it's going to be 6 pounds. Now for number 6. If the weight in the moon on the moon is 36, we want to know the weight on Earth. So we could divide by 1/6, or we can look at that second constant of proportionality. From the moon to Earth, our constant of proportionality is 6. We're multiplying by 6. So we're going to take 36 and multiply it by 6. That is 216. So if an object is 36 pounds on the moon, it is 216 pounds on the Earth. That is a crazy, crazy, crazy difference. Okay. Great job. Make sure you've got all this down. That was our last slide. And it is time to move on to our lesson synthesis. So, first of all, right now, raise your hand silently, please, and ask whoever is currently in my room for a lesson synthesis. It should be in a stack on my desk. Glue it into your notebook, and let's go ahead and talk about it. So coordinate points are written in the form x, y. X is the x-axis is horizontal. It goes from left to right, and the y-axis is vertical. It goes up and down. So we can interpret points on a graph in terms of the context it represents. The point K on this graph is the coordinate point 12, 24. Since x represents our pounds and apples, the x value, and the coordinate point 12 is the pounds and apples. That's what it represents. Since our y-axis represents the price, the y value in the coordinate point 24 represents the price. This means the coordinate point 12, 24 means that 12 pounds of apples cost $24. Pretty simple. The point 1, 2 on this graph, though, is very special because it shows our constant of proportionality for this relationship. The constant of proportionality is 2. You can always find the constant of proportionality on a graph by looking at the point 1K. K represents our constant of proportionality. It changes with every graph. You can also create a table to help you find this value. Setting your our x value, which is pounds of apples, down to 1, and then taking down our y value, and whatever is next to 1 in our table is always the constant of proportionality. You guys know that. You always tell me that about every single day at this point. Okay, now our lesson is completed. I hope at this point you have raised your hand and asked the teacher in the room very politely for a lesson synthesis. And now we got a few things you need to do now. Number 1, glue your lesson synthesis in. Glue it into your notebook. Number 2, okay, we're moving on to a normal day in class. Do your cool down on Go Formative. Should be pretty simple, okay? It's a graph. You got, I'm pretty sure 3, maybe 4 problems, but I'm pretty sure it's only 3. Very simple. Number 3, okay? Do your lesson reflection. I swear so many of you forget your lesson reflection. That is that paper in the notebook where you grade yourself. How do you think this lesson went? Was it easy? Was it hard? You tell me, okay? I'm not there to be able to determine how easy it was for you. Number 4, minimum 15 minutes on Edmentum. Required. Must complete. Okay. Last, number 5. Do your Homework on Edmentum. I know this is not a normal Friday, but we're pretending it's just a normal class period. You guys are used to doing quizzes on Fridays, but we did our quiz yesterday, so you got homework today in place of it. So complete your homework on GoFormative. At this time, make sure everything on GoFormative is done. Every homework, every cool down, make sure they're at 100%. If you cannot do it, like, complete to 100% without me, that's cool, okay? Make sure they're done, though. I'll help you on Monday when I get back. Get everything up to 100%. Just make sure all your homeworks and cooldowns are at least attempted and done. Last, choice board. Your choice board is the last slide of every single set of slides, every single lesson that we have done. If you go to the lesson that we just did, it is the very, very last slide. Okay, you got a bunch of stuff to do. Most of you are going to pick Prodigy. Okay, I'm cool with that. Do it. Have fun with it. I don't care. Remember, stay silent for the rest of class period. No names written down. Good behaviors only. Positives. Okay, if you want a sticker, if you get a positive when you get back, okay, I'll give you stickies. Good stickies, the stickies you get on your test. Okay, just good. No negatives. Okay, no negatives. I don't want to have to give any consequences when I get back on Monday. Okay, I love you all. Have a very fun and safe weekend, and I will see you all on Monday. Bye-bye.